Imagine stepping into the ocean and feeling crystal clear water, like stepping into a freshwater spring. No salty sting, no buoyant pull. But then, fish float lifelessly. Currents stop, storms rage unchecked, and the oxygen that keeps you alive vanishes. What just happened? What if all the seawater turned fresh? Overnight. Stay with me. This isn't science fiction. It's a question with deep scientific roots, and it will change how you see the world beneath the waves. Part 1. Why is the ocean salty? Rainwater becomes slightly acidic by absorbing CO2, eroding rocks on land and dissolving mineral ions that rivers carry to the seas. Sodium, chloride, magnesium, sulfate. Over geological timescales, these salts accumulate, balanced today by deposition and ongoing cycles, but still sustaining the ocean's saltiness. Additional contributions come from hydrothermal vents, seafloor mineral deposits, and volcanic activity beneath the ocean. Part 2. What if the ocean became fresh, suddenly? Collapse of marine life. Saltwater species, from algae to fish, are finely tuned to ocean salinity. Without salt, they can't regulate water balance and collapse. Many would perish instantly, disrupting the entire marine food web. Plunge in photosynthesis and oxygen. Marine algae, including phytoplankton, which contribute roughly half of Earth's photosynthesis, would vanish or severely decline. That yields a collapse in oxygen production and a spike in atmospheric CO2. The consequences? A supercharged greenhouse effect and rapid global heating. Breakdown of thermohaline circulation. Temperature and salinity differences drive the planet's ocean currents, like the Gulf Stream. Without salinity gradients, oceanic conveyor belts vanish. That means polar regions freeze, equatorial climates soar, and weather patterns go haywire. Collapse of global climate stability. With no salinity-based circulation, hurricanes go rogue, polar ice expands or melts erratically, and the climate fractures. You'd face relentless extreme heat in the tropics and freezing darkness near the poles. Part 3. Rippling effects on Earth's habitability. Deoxygenated and acidification shocks. Without healthy marine ecosystems to cycle oxygen and absorb CO2, ocean deoxygenation accelerates. That shifts marine habitats toward hypoxic dead zones and compounds acidification troubles. Biodiversity Armageddon. Coral reefs vanish, fish stocks collapse, and entire ecosystems dissolve. Studies show warm oceans repeatedly trigger mass biodiversity crashes over geological time. Loss of climate regulation. Oceans currently serve as massive carbon sinks. Without them functioning properly, CO2 accumulates faster, making the planet inhospitable. Human civilization teeters. Fisheries collapse. Oxygen starvation worsens. Arable land dries or drowns. And extreme weather obliterates infrastructure. Human society enters a tailspin, likely ending within years. Part 4. Lessons from real-world threats. Ocean acidification, the climate crisis evil twin. Rapid CO2 absorption is already driving down pH levels, and it's accelerating the erosion of marine life and ecosystem stability. Algal blooms in dead zones. Climate change and nutrient runoff are fueling toxic blooms that suffocate ecosystems, showing how fragile oceanic balance is. Conservation as a lifeline. Initiatives to protect marine habitats and biodiversity, like MPAs, rewilding, and algal regulation, are vital. The ocean plays a central role in climate mitigation and resilience. Epilogue. Why you matter, and why you should care. We just took a terrifying ride through what our world could look like if the oceans lost their salt. But it also shows how fragile and how precious this balance is. Our actions today, from reducing CO2 emissions to restoring marine ecosystems, determine whether that dystopian future becomes a reality or remains a thought experiment. The ocean's salinity is not just a scientific curiosity, it's life. Let's keep it that way.